Hello everybody, this is Todd Frazee and this is ADVM 68. We are going to be programming and setting up and programming part number 730001-101. It's a multi-tool and in this exercise I'm going to have you import a step file. So this would be simulating if you were to receive a file from a design from a customer and you don't have the opportunity to design it. And what we do is we import a universal file. And as far as Fusion concerned, it's what we call a dumb solid. You won't be able to change the model itself. So you have to learn how to machine the way that thing was designed. This hopefully will be a fun one. First, we're going to open the file. So to do that, we're going to go to Upload, and you're going to select your file. Now, it's going to be downloaded from Canvas. So I'm going to go to the location that I stored the file in and select it. It should be 73001-101.step. Okay, and we're going to open that file. And it's going to ask you where you want to put it. I'm going to put it in the location where I'm at. This takes a little bit of time to load, and you'll see it upload on the left. And the icon should show up the model. Depends on, this may take some time, so be patient. And then you can then open the file. Okay, so our file is this octagonal shape with a bunch of hex holes around the outside edge. We're going to use those to insert tool bits, like Allen size tool bits or screwdriver bits. And this can be used to hold up to 8 different tools. Okay, so the first thing we're going to do is we're going to do this as a 5-axis project, and we've had the luxury of having blanks pre-made with the Raptor profile for the Raptor vise. The Raptor vise specifications are also in PDF format on the canvas, but if we were to take a look at the profile, this is a standard dovetail preparation for the vise holding system. One downside of this system is that you have to have very tight tolerances on your prep, but it allows you to hold on to something with about 1/8 of an inch of thickness. So we're going to plan our stock around this dovetail and around a piece of material that's 1 inch thick from data May to its top. Okay. And so our dovetail feature will be on the face of that. So even though we've got pre-made blanks, we want to start off by modeling that blank, because in 5-axis it's going to help you with some visualization. So I'm going to flip back to Fusion here. And what we have here is our piece. And if we were to inspect it, it's a 3/4 inch thick part. Okay, so what we're going to do is we're going to create our volume, and it's a 2 inch by 2 inch by 1 inch volume that this part needs to fit into, plus stock to hold on to it with the Raptor profile. So let's start there. We're going to go and we're going to go sketch, and we're going to sketch on in the top plane. Okay, and we're going to draw our square. Okay, and from our vendor, this is 2 inch. The top edge equal to the vertical edge, which gives us a 2 inch square. And then if we take our take a line and go from corner to corner, we can convert that into a construction line by right-clicking on it. We get derived at this, and we should be able to midpoint relationship with origin, which puts our volume centered on the face of this. Okay, so we're going to finish our sketch. And the blanks we got are machined on the face, but we do want to cut a little bit off. That way we are sure that it's all true to our setup and our machine. So we're going to do an extrusion. Extrude this. We're going to hit all of these faces. We're going to create a new body. Okay, we don't want it to join because this is going to be stock. And we're going to go ahead and go in two sides. Okay, and in the first direction, let's go 30 thousandths. We just want a little bit of material. Okay, in our opposite direction, we're going to go a 1 inch minus our 30 thousandths. So our total stock volume is 1 inch. Make sure that your setting is on new body, and we're going to hit OK. Now if we go to our bodies, we have part 1, which is part we imported, body 2, which is the stock. So I'm going to change this to the name of the second body to stock. Okay. And so if we make that body invisible, we see it there. What we're going to do is we're going to right click on the stock and we're going to make it 50% opaque so that we can see our part inside it. All right, so this is our piece of material, not counting the dovetail. Now we do want to leave a fair amount of room on this side because our cutters may need to go past and we don't want to hit our vise and our 5-axis fixture. Okay, so here we go. We're going to add the dovetail fixture to this. And to do so, I'm going to do a sketch on what was called the back there. And if we go back to our dovetail feature for 3/4 inch, it's nominally 3/4 inch, but the measurement over pins is 879 thousandths plus or minus 2. And it's going to be centered on our block, and then we have this shape. So we're going to actually model it just like this drawing shows. Let's zoom in. Okay, so we're going to draw pins on either end so we can get the width right. And those are going to be just construction circles. Okay, and that will allow us to put our dimension across the face of it. And then drive it where these angles go. Okay, and then we have our profile there. All right, so let's flip back to our sketch. We're going to start off selecting the side of the stock, doing it at an angle. We go straight up, across, back down, another angle. Draw a circle and then another circle. We're going to take and we're going to convert both those circles into construction geometry. We'll dimension one of them. Okay, it's just going to be our 100 thousandths. This represents the pins. And then we're going to make an equal relationship between the two circles so they're the same diameter. We can then set our angle for the dovetail, which the drawing says it's 60 degrees. It's 60 degrees. I'm going to do the same thing on the opposite one. And then our little leg here is 2 times 35 thousandths plus or minus 2. So we're going to dimension one of those legs. can use the equal relationship again. Okay, so both of those are the same size. Then I'm going to draw a line from the midpoint of our dovetail feature, and we're going to go to the center of stock, right here in the middle. Okay, if I create that as a construction line, and I force that to be vertical, I've now forced this entire shape to be on the center of our piece. Now, we're going to use the tangency command to make this first pin tangent to the vertical, to the 60-degree angle, and then we can insert, make it tangent to the top of the part. Repeat that in both places. And if we go back to our drawing, the measurement of our pins is 879 thousandths plus or minus 2. And that's to the tangency points outside the pins. Flip back to Fusion. So to dimension two circles from tangency point to outside, rather than just picking on the default, we're going to right click on the first circle, and instead it says defaults to the pick circle and arc center. We're going to pick to circle arc tangent. We're going over the first circle, then our second circle, and we get our distances across pins. And that's 0.879 is our dimension. Okay, so that gives us our width. The only definition we have left to do is the height of our material. So let's go back to our drawing, and it says it should be 124 thousandths minus 1 plus 0. Okay, so it's very specific. Go back to Fusion. Dimension from top of the dovetail to the top of the part. We put 1.124 or 124 thousandths. Okay. That is the profile of the dovetail extrusion that we're going to shoot across the length of the part. Let's go ahead and hit Finish Sketch. Let's look at it in a 3D view. And we're going to extrude that shape. And we're going to go to Object. And we'll select the other side of the part. And that will shoot it all the way across the full length. And in this case, we do want to join to the stock body. Okay. Now, if we go back to our drawing, they have a notch in this. And we have a fillet that we needed to add. I'm going to add this fillet after the fact. Once because I forgot to put it in there, but also it's a little bit easier on the dimensioning. So let's put in our fillet. Okay, so now we're going to put our fillet, and according to our drawing, it is 15 thousandths. Go back to fillet, or select either side of the model, and 0.015 or 15 thousandths. And I could have put that in my drawing profile when I extruded that across. My practice is not to do that on very small fillets. Allows you the flexibility to change it. Doesn't muck up your dimensions and intersections. Okay, so now we need to put the notch in the top. And according to this, it is a 269 thousandths plus or minus 1 slot. And there's a pin on the Raptor vise that allows you to load it and make sure that it's not loaded backwards and that it's pretty much centered on the center of your fixture. And this is good for 4 and 5 axis because when you put your blanks on it, you don't have to indicate them in and where the location is. It's repeatable. And so this notch feature is just straight in. We use an end mill to cut it. And it looks like it's off-centered by 35 thousandths off center line of the part and 269 thousandths in width. So let's go back to our Fusion, and we're going to create a new sketch to create that feature on the top of our part. Okay, we're going to sketch from the edge of our part where the silhouette starts. We're going to come straight in. We're going to click, and then we're going to click and hold the button down, which allows us to draw a radius. We're not going to worry about the size. We're going to let go, and then draw the line right up to the edge on the other side. We then drag this down, and now we'll make it horizontal with origin. Okay, now that we have it horizontally constrained, we're going to now dimension from origin to the crest of the arc. So if we right click instead of left clicking, we can pick on circle to arc tangent. And that allows us to give the dimension as it is on our Raptor profile print. So on that, it was 35 thousandths. So we're going to put in 0.035 or 35 thousandths. And that gives us the proper position of it in the horizontal axis. Now, our width, according to our drawing, is 269 thousandths. We'll go back to Fusion, and we're going to put in the width of our slot. It's 269 thousandths. That gives us our profile. Our sketch is fully constrained. We can now finish sketch. And we should be able to do an extruded cut. So we're going to pick our zone. And we're going to do a cut. And it's going to be up to object. And we'll select the plane of the back of our profile there. And it'll cut out our button notch. Okay. Now we've done this. If you were to need to machine this feature, you would go through a procedure to cut this with a dovetail cutter and a cutter that's smaller than 269 thousandths, so a 1/4 inch end mill should do a nice job of that. I'm not going to go through that because this particular part is already prepped, but there will be another video on how to do that dovetail prep for this type of profile. When you machine it, you do need to measure it over pins. This vise system is very particular on its tolerances. Okay, so you may have to compensate at the machine. And I'm going to go ahead and while we're in here, I'm going to change the name of body 1 to the part number. Okay, so we've differentiated the two bodies, the stock and the model. We want to make sure we're saved, and we're saving often. Okay. Now that we have our stock and our part on two separate bodies, we can hide and show which one we need and differentiate them for when we go into manufacture mode.